Hey, this video is going to cover section 4.3, which is rotating figures and images in the coordinate plane. All right. One very important thing to note is that when we perform rotations, the default direction is to rotate counterclockwise. So we have here a bunch of rules for how to get the coordinates of a rotated image. So for rotating just 90 degrees, what happens is the coordinates swap positions, right? And what was the y coordinate will also change its sign. For rotating 180 degrees, you just change the sign of the original coordinates. For rotating 270 degrees, the two coordinates will swap positions, and then also the x coordinate will change its sign. Okay, so honestly, like, these rules are very confusing and they're hard to remember. So I'm going to share with you a little hack on how to perform rotations. All right, so here are our practice problems. Okay, we'll look at, so let's look at the directions. Okay, so graph the image of the polygon after a rotation of the given number of degrees about the origin. All right, so question number one, we're going to rotate 180 degrees. Remember, the direction will always be counterclockwise. Okay, so here is my hack, all right, is to use tracing paper or patty paper. Okay. So I've lined everything up, and then I'm going to use my pencil to hold it there in the origin, and then I'm going to turn counterclockwise. Okay, so that was a 90-degree turn, and then I'll do that one more time. Oops. All right, so 2 quarter turns as a half turn, that's 180 degrees. Okay, so the original image is right there, but the rotated image, if you can see, is right here. Okay, all right, so that's my little hack for how to perform rotations. You just use some patty paper, tracing paper. All right, let's try that on question number 2. Okay, so I've already prepared everything. Okay, so here's our original triangle, and we're going to rotate 90 degrees. So that's just a quarter turn. Okay. So I'm just turning until the axes line up again, right? So that's my quarter turn. Okay. All right, so here is the new triangle. It's down here in quadrant number 3. Okay. All right, next problem is a quadrilateral. A, B, C, D, and we're going to do 270 degrees. So that's going to be 3 quarter turns. All right, so that's my first quarter turn. That's a 90-degree rotation. Okay, there's another quarter turn. That's a 180-degree rotation. And here is my last quarter turn. Just lining everything up again. So that's 270-degree rotation. Okay, so now the quadrilateral is over here in quadrant number 4. Right, so we can mix and match rotations with other transformations such as reflections or translations in problem 5. Okay, so let's take a look and see how that would be done. So when we're doing multiple transformations, it's important to do it in the order that it's given, right? So the reflection is the first thing, so we're going to do that first, okay? So I want to reflect across the x-axis. So what I'm going to do is just take my little tracing paper and flip it over, right? So what was, on the top half is now in the bottom half and vice versa, okay? So that's my reflection across the x-axis. And now I'm going to rotate 180 degrees. So holding the origin in place, we're going to do, that's 90 degree, and then that is 180 degree. Okay. So now my segment is going to be over here. All right, so this would be M prime, and this would be N prime. This is the original segment there. Okay. All right, number 5, we're going to do a rotation followed by a translation. Okay, let me move this so I can see. So let's rotate it 90 degrees. Okay, remember that's always counterclockwise. Okay, and just line things up again. All right, x plus 2 means we're going to go 2 units to the right. So 1, 2. Y minus 3, we're going to go down 3 units. 1, 2, 3 units. Okay, so here's where the new segment would be. Right, this would be n prime. This would be m prime. All right, let's switch to some more composition. So now we're going to do a rotation followed by a reflection. Okay. So we're going to rotate 270 degrees. So that's 3/4 turns. 1, 2, and 3. Just line things up. Okay. And then we're going to reflect in the line y equals x. Okay. So the line y equals x is going to be this line right here. Okay. So what I want to do now is just flip my little tracing paper over, making sure I line that up one more time, right there. Okay. And so here's where the new segment would be, m prime, n prime. Here was the original segment, okay. I want to do that one more time. Okay. So here's the original, okay. 270 degree rotation, so that's 90 plus 90, so 180, plus another 90, that's 270, okay. And then this diagonal line is the line y equals x, so I'm flipping it over across that line. Okay, and so there's our new segment. Okay, question 7. We're going to rotate and then translate. Okay, so 90 degree rotation is a 1/4 turn, counterclockwise. Okay, and then what does it say? X minus 5, so that's going to be 5 units to the left. 1, 2, 3, 4, 5. Okay, there's nothing next to y, so we're not moving up nor down. It's just going to stay where it is now. So there's our new segment. This would be n prime, m prime, and m, the original over there. Okay, let's see. Questions 8 and 9 says graph triangle JKL. I've already done that ahead of time. So J is at 2, 3, K is at 1, -1, and L is at -1, 0. And then we're going to perform multiple things, a rotation and a reflection here. Okay, so let's grab this. Okay, so we'll do a rotation of 180. So that's a 1/2 turn. And then we want to reflect across the line x equals 2. Okay, so x equals 2 would be this line right here. Okay, x equals 2. Okay, so I'm going to flip the paper over, making sure that I line that line up with where it is right here. X equals 2. We just want to keep that line where it is. So we're going to flip like this, making sure we line that up again. Okay, and so here is our new triangle over here. Okay. All right, number 9 is a translation first. So x minus 4, that's to the left. 1, 2, 3, and 4. Y minus 4 is down. So 1, 2, 3, and 4. And now we want to rotate 270 degrees about the origin. Okay, so this is the original origin, which is right here. Okay, so I'm going to use my pencil to hold the paper still in that spot. we're going to do 270 degrees. So this is quarter turn for 90, another quarter turn for 180, and then our final quarter turn for 270 degrees. Okay, and so here is the image of the new triangle right there. All right. Yeah, I think I did that right. Let's just double check. 1, 2, 3, 4. 1, 2, 3, 4. Hold it at the origin. Rotate it. Yeah, okay. All right, last two problems don't have any coordinates, okay? It's just some shapes, and we want to know whether these shapes have rotational symmetry. All right, so rotational symmetry means that if we rotate the shape around its center, we can somehow get it to line up with itself again, okay? So there I did a turn, and the pentagon lined up, and here I can turn again, and it lines up again. Okay, and then I turn again, and then I turn again, and then I turn again, right? So how many turns did I do, right? So here, let's just put like a letter T here for the top, okay? So how many turns did I do to get back to the original position? So this is 1 turn, 2 turns, 3 turns, 4 turns, and then 5 turns. Okay, so it's 5 rotations, right? And each time I rotated, it lined itself up again. Okay, so how many degrees was each turn? Well, since we got all the way back around again, altogether we went 360 degrees, but that was 5 turns to do it, right? So 5 rotations equals 360 degrees. So let's divide by 5. So each one of those rotations that I did, rotations, is equal to, what's it going to be? 360 divided by 5, which is 72 degrees. All right, so this pentagon has rotational symmetry. Every time you rotate 72 degrees, right, the pentagon lines up with itself again. Okay, and then here's our final image. Okay, just some funky quadrilateral, right? All 4 angles are different, right, because they have different markings. This is a single arc, a double arc, a triple arc, and a quadruple arc. And so we'll try to rotate it around its center. And, you know, does it ever line up? Well, no, not really. Not until we go all the way back around, right? But everything would line up if you did 360, right? So we would say this shape has no rotational symmetry. Okay. It only has rotational symmetry if you can rotate it, I believe, if it's an angle that's less than 180 degrees.